Chance to try number 37. Again, I just want to go over the highlights like we did for number 36, just so you know you're on the right track in case you can't read it in my notes and checking your answer. So here, when you work this one out, you get A8 is 800. Okay, if we have 24 monthly payments, again, we're converting those to quarterly. So remember, 3 months are in 1 quarter. So if we divide 24 by 3, we get 8 quarters. Okay, that's where A8 comes from. When you find your quarterly payment, that's going to be R. So again, that's your quarterly payment. It's going to be R, and that should be 1,130.06. Okay, again, we're rounding to the nearest penny, so it's 2 decimal places. When you find your monthly payment, okay, here your timeline is going to be this, and you got your 1 month, 2 month, and then down here would be 3 months. I know it's not to scale, sorry about that. And again, these would be your X's, so you move this one 1 month, this one 2 months, this one will move all 3 months, this would be your R. Okay, just to help you think it through with your timeline. And when you find X, you should get 373 and 21 cents. Again, we're rounding up the payments. Okay, so it should be your final answer. So now we're going to cover the last part of this general annuities section, and this one has to do with continuously compounded interest. Okay, so here we have the same type of timeline. We still have P over here and S over here. Remember, this time when we're dealing with compound interest, you have S equals PE to the RT, where R is in years, so this is your forward. And then your backward is going to be B equals SE to the negative RT. That's your backwards. Okay, and T is always in years, just like before. Okay, so we're plugging that whole thing into the exponent, so that's a little different. And then our other formula that we need is the EIR, so I'm just going to put that down here. So your EIR is going to be E to the RT minus 1, but this time instead of being, T is going to be a fraction of a year. So T is still in years, even though we're finding the EIR. And again, we're going to do that and store it as A because we're compounding continuously. So whenever we see that word compounded, you're assuming compound interest for 1 period, or if it's not noted, we assume compound interest for 1 period. And at that point, that's when we use the EIR. If it says simple interest for part of the period, that's when you do the 2 timeline method, and you have to work a couple different timelines. Just be careful there. Be careful. All right. So the size of 1 monthly payment if the first payment is made 1 month from now. So the first thing we do, of course, is our timeline. So an amount is borrowed. So that means it goes at the beginning. Borrowed is a word that tells us beginning. Okay, and 6 years, so we know how long this is, 6 years. And we're doing 8.2% interest, so our R is 0.082, and that's continuously. And we want to find the size of the monthly payment. So we're making 1 month payment, 2 months payment. Okay. So what we have to do is we have to convert this continuous interest rate to a monthly interest rate. Okay. So our T here, where we're finding our EIR, is going to be 1/12, because we're doing 1/12 of a year. A month is 1/12 of a year. Okay, so that's where that comes from. So when you input that in your calculator, you have to be careful because you want to make sure you get the whole piece in there. So we get E, and then it automatically comes up with the to the for me. So 0.082 times 1/12, because that whole piece is in the exponent. Okay, then we subtract 1. So I'm just going to write my approximate down for good communication to me and other people, and maybe future me. And we're going to store that as A. So I hit store and then alpha A to store that as A. And then now we have to figure out how many payments are made. So if we're doing monthly for 6 years, 6 years times 12 payments a year would give us 72 payments total. This is just a straight up A sub n problem, so we do A72 is our 2250, or sorry, 22,500. Point 1 plus A, remember that's our A, our effective interest rate, to the negative 72 all over A, and then we're multiplying R by that. So again, just to be consistent, I'm going to find whatever this coefficient is for R first using my A. So I do 1 minus 1 plus A to the negative 72 divided by A. So we get 56.67. So then our R is going to be 22,500 divided by that, so 22,500 divided by answer. And our regular piece here is 397.01, because again we're going to round up for payments. That ends section 3.4 and chapter 3. So now what we're going to do with chapter 4 moving forward is home loans. So it includes everything that we've talked about so far. Most of it is called home loans and amortization. So that's going to be next week.